Today we're going to be talking about slope of lines. Our objective is that we'll be able to find the slope of a line given the graph of a line or given the coordinates of 2 points on the line. We'll be able to use slope to determine if lines are parallel or perpendicular. And given the line, we can determine several points that make up parallel and or perpendicular lines through another given point. So as a refresher, from Algebra 1, slope is rate of change, which is rise over run, or the change in y over the change in x, or our formula is y2 minus y1 over x2 minus x1. As for the slope of parallel and perpendicular lines, parallel lines have the same slope. Perpendicular lines have slopes whose product is -1. In other words, their slopes are opposite reciprocals. So here, if you look, if we pick 2 coordinates on A and 2 coordinates on B. To get from one to the other, we have to go up 3 over 1. So the slope of A equals 3 over 1. And the slope of B is also equal to 3 over 1. A reminder that you can also mark up here, this is equal to m. M is the letter that we use to represent slope. For perpendicular lines, if I choose 2 coordinates, the slope of J is equal to 3 over 1. But for K, I go down 1 and over 3, so the slope of K is -1 over 3. So they're opposite because this one's positive and this one's negative. And then reciprocal means flip over your fraction, so 3 over 1 and 1 over 3. So let's determine if the lines are parallel, perpendicular, or neither. The first thing we need to do for both is calculate the slope of each line. So x1, y1, x2, y2. So -1 minus -4 over -1 minus 6. Now you may have noticed that I did y1 minus y2 and x1 minus x2. These are interchangeable as long as the 1's are lined up and the 2's are lined up. You'll get the same answer in the end. -1 minus -4 will give us +3 because minus a negative changed to positive. And -1 minus 6 is -7. For line 2, we're going to have 7 minus 0 over 7 minus 4, which gives us +7 over 3. One's negative, one's positive, so they're opposites. They're also reciprocals, so the lines are perpendicular. For our second 2 lines, line 1 and line 2, we have 2 minus -4 and -3 minus 0. 2 minus -4 is 6. -3 minus 0 is -3. And 6 over -3 simplifies to -2. For line 2, we have -8 minus 0, -2 minus 2. We get -8 over -4, which simplifies to 2. They are opposites, but they're not reciprocals, so they can't be perpendicular. They're not identical slopes, so they're not parallel, so these are neither perpendicular nor parallel. Let's look at graphing. Given a parallel line to the given line, graph a line parallel to the given line through the point provided. Plot at least two other points with integral coordinates. That just means, integral just means positive or negative whole numbers. So first we need to find the slope of this line. So I'm going to pick out 2 points on the line. And from that I know my slope is -1, +2. So the slope is -1/2. Since we want parallel, we're going to use the same slope from this point. So down 1 over 2, down 1 over 2. We could also go up 1 and left 2, up 1 and left 2. Don't forget, since we're drawing a line, we want to have arrows on the end. Now we're going to graph a perpendicular line to the one given. Since it's the same line as before, we know the slope is -1/2, which means our perpendicular slope, this one was negative, so the perpendicular would be positive, and we flip it over, so it would be 2 over 1. So from here, up 2 over 1, and since we ran out of graph paper, we can do down and left, down and left, down and left, down and left. Find the value of x so that the line passing through the 2 points has the given slope. So we want to figure out what this coordinate is, this missing x value here, if we use the point 1, 2 and have a slope of 3. So coordinate 1, 2, and a slope of 3 means we're going to go up 3 and over 1. So remember, 3 as a fraction would be over 1. And I'm just going to keep going until I've made the line that fits the entire graph paper. So 1, 2, 3, 1, 1, 2, 3, 1. Now one of these dots should have a y value of -7. So 1, 2, 3, 4, 5, 6, 7. It's this coordinate right here. And the x value at that coordinate is -2. So x equals -2. Now let's see how that pertains to parallel and perpendicular lines. You can solve these by either graphing, or we can solve it algebraically. So I'm going to show you one of each. Given that a line passes through the points A, 1, 5, and B, 2, 3, plot the points P, -3, 1, and Q, -4, n, so the n is what we're looking for, that make up a line parallel to AB. So A is 1, 5, and B is 2, 3. Connect those and make my line. And that line has a slope of -2, 1. So AB slope equals -2 over 1. Since I want a line parallel, my new line is also going to have a slope of -2 over 1. So I'm going to plot -3, 1. And I know from there I'm going to go down 2 and right 1. And I can also go up and left. So we want the coordinate on there that has an x value of -4. So 1, 2, 3, 4. That's this coordinate right there. What is that y value? It's 3. So n equals 3. We can also do this algebraically. So the slope of line P is -2. Given the points A and B, find the values of n so that AB is perpendicular to line P. So we need to find the perpendicular slope. Since this one was negative, our new one will be positive. As a fraction, this would be 2 over 1, so our new slope would be 1 over 2. So we know that 1/2 has to equal our slope formula. So x1, y1, x2, y2. So we know that -1 minus n over 5 minus 3 has to come out to equal 1/2. So we're going to cross multiply. We're going to have 1 times 5 minus 3 equals 2 times -1 minus n. 5 minus 3 is 2, and 1 times 2 is 2. Over here I'm going to distribute because we have a variable. -2 minus 2n, and now we're going to solve. Add 2 to both sides. We have 4 equals -2n. Divide by -2. Divide by -2. And we get that n equals -2. Go ahead and fill in your summary, and I'll see you